Hello, everyone, and welcome to a KDAB Insights production for our YouTube channel, KDAB TV. My name's Frances Tate. I work for KDAB, and I'm delighted to introduce our participants in today's discussion about the future of C++. Before we get started, Evan, I wonder if you could briefly tell us a little bit about C++, its ups and downs so far, and what got you so passionate about it, and why we should care about it at all.
So for me, C++ wasn't really a language that is particularly nice for young people a long time when I was young. But at some point, I joined KDE and I saw the power that C++ has. Unfortunately, in that era, C++ kind of got a little bit less popular due to some nicer to use languages. I'm not going to mention any names. But all those languages claimed to be nicer by removing some or many C++ features. And after a while, you just realize that using languages that are just subpar is not good enough. C++, for me, the main benefit is that you have an enormous power. You can go as low as the hardware or as high as the clouds. So it's probably the only language in which I was able to write really low-level code and at the same time develop stuff that ended up in functional programming for C++.
Can you tell us a little bit about the history, the point where they started to do the C++ standard?
Okay, so the first standard of C++ was in '98, and it was a significant milestone. But after that, C++ kind of was stagnant for a long time. And people thought that it has died. And all those other alternative languages tried to overtake it. And some, let's be honest, kind of succeeded. But at some point, people started carrying around little devices like mobile phones that run on batteries. And battery life became really important. And at the same time, for big server farms, the most expensive thing to have is the electricity. So people started caring about the performance of their software, and there is no language that can compare to C++ as far as the performance goes, and performance and abstractions. So not C, not Java, not any other language.
Each of you has contributed to the spread and growth of C++ in the ecosystem. Why? What inspired the rest of you? Perhaps I could start with Kalle as a business owner.
Yeah, so at that time, we at KDAB were in a bit of a difficult situation. So to give a bit of a background, because I'm not sure everybody is aware, our business is to support our customers succeeding with their projects, the software development projects based on the Qt framework. And Qt essentially supports two implementation languages for application writers. C++ for the back end, and for the front end, you have the choice between C++ and QML, which is essentially JavaScript based. We have seen many customers who drew the line between what gets implemented in C++ and what gets implemented in QML JavaScript too far into the back end, so algorithmic bits of the code that should have been for speed and energy efficiency should have been implemented in C++ were implemented in JavaScript just because that's what they had more developers with or had the greater familiarity with. And so we saw a need to educate our customers about sort of where to draw the line, at what point to hand over between the two, or even keeping the option open of even developing the front end in C++, which is still perfectly possible. But also, we also saw that we had a hard time recruiting C++ developers because there was there weren't not a lot of college curricula that actually used C++ as an implementation language. We had the need to get the word about C++ out to a greater audience. We also saw the somewhat weird situation that C++ was used as an implementation language in so many things, browser engines, and in finance, it's the high performance finance computing. It's the main implementation language, but so there must have been an ecosystem, but it was essentially invisible because there were hardly any conferences. There were not a lot of books published. There were little. There were a few podcasts. There was little on YouTube. So when Jens came and approached us about running a C++ conference, that was just was a perfect fit for us at that point.
Fantastic. And John, in America, you were involved in the C++ community as it developed out there. How was it for you? Did that happen before Jens's meeting C++? I was interested to know whether America came first.
So there was a conference in the US, a big conference that actually focused more on software development than on C++, but most of the attendees were C++ programmers. And that conference announced, we're not doing this anymore. They no more. And that was a little bit upsetting to me because there was no C++ conference in the United States, except there was a conference that was actually focused on Boost. It was BoostCon. And I had been attending that. And it occurred to me that this is the closest thing to a general C++ conference. It was mostly general C++ content, kind of cutting edge library focused stuff, but the name was Boost. And so I actually approached the organizers and said, let's rename the conference. Let's focus on C++. Let's grow the conference. Let's make it the conference that doesn't exist. And that was successful. In a sense, we changed the name. And the very first year that we had it as a name under C++ Now, we had an attendee that showed up, and he actually left his mark on the community, and that was Jens, who attended the first C++ Now and came to me and said, "Hey, I'm going to have a conference like this in Europe because there needs to be one." And I think I told him this. I was all enthusiastic, but I didn't think he could pull it off. But that very year, he pulled off. That was 2012, and he pulled off a great conference in Europe. Had more attendees than we did, and it's been growth and growth and growth and excitement ever since for him. But what was going on in the U.S. was, my vision was to kind of take the conference and be a major C++ conference, a mainstream large conference. And I began to realize it was a little bit disappointing that wasn't a good idea, because it might not be successful. It might not become the conference I wanted, but I was risking destroying a really good conference, a small conference, not really mainstream, more, as I said, focused on libraries and things. But and so I realized, no, we would have to start from scratch to build a conference that was its intent. And that was kind of the history of CPPCon. That's what we decided to do, was we'd start a new conference. And so both conferences now exist. But that's kind of the story of how I got involved and what I've been trying to do.
Okay. And Jens, perhaps you can finally tell us.
So looking back at 2012, I've been for about 5 years a freelancer. And for the last 2 or 3 years of those years, I specialized in C++. And prior to that, I had a long time experience of serving the C++ community. And in December 2011, I started a C++ user group. And prior to that, I've already been involved in community work for Qt and MeeGo, which was a mobile operating system. And I kind of had this idea of 2012 and 11 were really good years for me, that I actually would be able to start a conference and see, as a one-off. But then I happened to meet John and a lot of others, and especially most of the Europeans which were at C++ Now, kind of talked me, or I talked myself into doing it. And on the other hand, I kind of, as a freelancer back then, realized during C++ Now that we needed kind of a long time perspective for C++, and that not a lot is being done in terms of media coverage, of community work, of just connecting people for C++ and just having this as a resource. And I kind of during that time, and it just came up a few weeks ago, asked me and myself, and like, how can we possibly teach the new standard to the masses which are out there wanting to learn C++ if we don't have the proper conferences? And on the other hand, I also was, we kind of have to reach out to reach into the talent we have to find a new generation, because I kind of realized that from that point we would have like 10 to 20 years to grow a new generation that then would be able to step into the footsteps of well-known people, like, which have been involved with C++ and which at some point would retire. And just a few weeks, I've seen that one of the founders of Boost unfortunately has passed away. And so, yes, we are losing or still having this foundational generation of C++ around. But back then, I kind of realized that we as C++ have to see that we get better in having something that cares for the community and that enables us to let talent grow. And in the decades since, I would never have thought that we would, go that crazy with multiple standards, large conferences, and a global community as we have today.
So what kind of numbers are we talking about? Because when you first began, there would have been how many people who came to the first conference, and how many people are coming now?
Well, at the first conference, we had 600 people, which was the largest C++ conference that had ever been held. And today, that would not be the largest. I think Jens has got more than 600. I think the one in Russia is more than 600. I think there's a few that are more than 600. Of course, we've grown the last year because in 2020 we did it virtually, but the last time we had a physical meeting we had 1,400 people. So there's been a lot of growth.
1,400, okay.
Yeah.
Wow.
And it's really hard to predict what it's going to be this year because we're doing it in October. By then, we hope we can do physical meetings. We hope to have a lot of people turn out, but there might be a lot of people who, for one reason or another, not want to travel. So it's really hard to know where we're at. But that does give you a sense. I mean, our conference was growing at about 20% a year, something on that order, and that's and that was at a time when many other conferences were coming into being, a lot of regional conferences. And I think is that CPPCon is growing not because there wasn't any other alternative for people to go to. It was because people were really hungry for this kind of community.
And we've got the likes of Google and Microsoft, as it were, investing in it now, which is certainly new, as it were, from the very early, or maybe they were there right from the early days. You tell me.
Well, I think that there was. I mean, it's hard to speak for these companies, but one of the things about C++ is it's never really been associated with a particular company that picked it up and carried it. It of course came out of Bell Labs and AT&T. But AT&T's position about C++ was that it was a tool that they were going to use internally. There's now a foundation, the Standard C++ Foundation, which has been supported heavily, as you said, by Microsoft and Google. But that came about, I'm not sure the exact date, but it was about the time frame we're talking about, 2010. It may have started in 2009 or 2009 or something like that.
So it's relatively new, all this stuff, really.
There's been a huge revival. And that's kind of, the book that I wrote and showed up was basically about what this revival was. And that's why I gave it the subtitle, The Beast is Back, because C++ is very old, a lot of legacy, but it became a force again at about 2010, 2011 with the new standard. Yvonne had pointed out, he said, it was stagnant during the 2000s. Standards Committee didn't release a new version of the standard for 13 years. That's just amazing, from 1998 to 2011. But the interesting thing is that the committee wasn't wasting its time. It was meeting. It was, but it didn't actually ship anything. And so when it did ship in 2011, the rough measure is the number of pages in the standard, which almost doubled between 1998 and the new release in 2011. And that tells you there were a lot of new features in the language, a lot of things that were just modernizations like lambda expressions and ranged-based for loops and things like that, which other languages, if you were a modern language, you had those things, and C++ didn't have those things. But in 2011, it comes out, it has that, it has multi-threading, it has an awful lot of stuff, and it's almost like, gosh, it's a brand new version that happens to be completely backwards compatible with what we've been using for decades. People began to understand that performance was more important than we thought. I think there was a feeling in the 2000s where we had these desktop computers that were just so powerful that you didn't really need to worry about performance. You could use a language that just threw performance on the ground. It wasn't that important because our processors are so powerful. But it turns out desktop machines are not really computers anymore. Computers are now smartphones or cloud computing. And in both of those, you're now back to thinking about performance again, either because of battery or because in the case of the cloud infrastructure, you're looking at power. But in both cases, performance is now really, really important. It's not like, the joke about desktops was, well, how fast does a cursor have to blink, when you're sitting there with your word processor? You don't care about more performance if you're talking about a fully loaded desktop machine. That's not the issue. And so that's why people were looking at languages where performance was less important, but ease of programming was important. So programmer productivity. But C++ has always been about, no, it's the final result. And what the Standards Committee has been doing, I think, to a great extent, is trying to figure out ways to add productivity without compromising the end resulting performance. In other words, what kind of tools can we give you that make it easier to program, make it easier to communicate your ideas, the high-level abstractions that Yvonne was talking about, like functional programming. We want that, but we, as C++ programmers, absolutely insist that it has to be done without compromising performance. And that's a really tough standard. So there are some other languages that are trying to come into C++'s space as supporting high-level abstractions, but also systems languages that can do the low-level performance that you can see in C++.
So that might be a good moment for me to interrupt and segue to ask each of you to consider, what next?
Yeah, I had my time to think about that. And I think from 2010, 11, 12, we were in that sweet spot that you couldn't scale by hardware anymore. And from 2015, 16 on, you could scale by hardware again with the cloud, but it would cost you a lot to, just add servers in the cloud. You could do that in theory, but you would be really expensive that way. And that's kind of the sweet spot where those new languages come from, that they, now also have to focus on performance. C++ definitely is on the top, and there's some other new languages which try to compete in that. And of course, there's going to be some new startups which have the luxury to fully implement everything in those new languages and then find out if that works or not. But if you look in the industry and the code bases which exist for the last 10, 20 years, you're not going to replace and rewrite all of this legacy code. And so I think if I see what's ahead, I think that C++ has become really competitive to those new languages, because also C++ has become a moving target, and we standardize and we implement, and we have different implementations, not just one implementation as those languages usually do. And so I'm not worried. And I think that for the standardization, it can be a very good thing to see what other languages do. And amongst people at C++ now, Haskell has always been popular to look at what is Haskell doing, and Haskell has never become mainstream because it's just Haskell. And so I'm not afraid of other languages.
If I may, it's it's part of my job here at KDAB to keep abreast of where our industry is moving to make sure our offering to our customers remains relevant. So I spend quite a bit of time looking at what's going on in the programming world, looking at different languages, frameworks, environments. And there's a repeating pattern that I see is that all those new kids on the block, the Rusts and the Darts and the Haskells of this world, they are solving problems now that the C++ community solved a long time ago. I'm just making up a number that C++ solved 15 or 20 years ago. So if you look at the kind of things that are getting fixed by the C++ committee in the standard right now, these are, to the casual observer, these are so intricate details that many C++ developers will never even notice them, either because they are of relevance to library writers only, or because compiler magic will make things happen for them automatically. Anyway, whereas if I look through the change logs of Dart, for example, which is a very I don't want to say anything bad about Dart. It's a very promising and interesting language, and I had some fun writing code in it. But the things that get fixed in Dart are quite fundamental at this point still, which is to be expected. I mean, it's a very young language, so it looks like it's moving at a much more rapid pace, but that is because it has so much to catch up, and that's the case for all those new languages. If you're looking for a stable environment where you actually know what you're developing for, then any of the in quotation marks legacy languages like C++ would certainly be a better choice. And then I can only confirm what Jens just said. Legacy code matters. We are frequently confronted with gigantic code bases of legacy code, millions of lines of code, absolutely not unusual. And you're not going to go and throw all that away. There have been in the past, there have been some attempts of actually throwing all of it away. Mozilla probably being the most dramatic example, but there were many others. And I think everybody has understood that code that has been written and tested for years and decades, that's a tremendous asset that you certainly want to improve and modernize and get ready for the next decennium, but that's not something that you just outright throw away and replace it with the hot new programming language du jour.
If I can add something. So to connect to Jens and Kale's comments, C++, so we have a lot of new programming languages coming around, and all of them focus on specific things, doing them really, really good. And they kind of restrain the developer to a specific paradigm or specific type of work. With C++, what I think that those languages are awesome because they will teach C++ developers how to write better C++ code. I don't think that they can ever replace C++. The good thing about legacy code and transition to modern C++ is that it can be gradual, unlike what Kale mentioned, Mozilla rewriting everything from scratch. So if you already have a huge project, you can just start improving piece by piece and moving to, let's say, C++ idioms and standard versions, and not rewrite everything from scratch in a completely different manner. And that's one of the things that I really love about C++, that it's a truly multi-paradigm language. You can mix and match different paradigms in different parts of your project as you see fit, and just to make the code more safe, more performant, and everything else. And that's not true for most other languages.
I think the unique value proposition of C++ is that it has the legacy, it has the community, it has lots and lots of libraries, tools, platforms, all this training, all these kinds of things that are non-trivial. That doesn't happen overnight. That's community building that has taken on years and years and years, something that that all of us here have been part of, and that doesn't just happen. So we get a new language, and they learn from the baggage that C++ has, and so it's a sexy thing. It's a green field. They can do all sorts of neat things. And if C++ was standing still, then it would just be a matter of time for these other languages to defeat it. But C++ is not standing still. The community are well aware of what these other languages are doing, and where we want to take the language, which is, better productivity, better safety, being able to write code that expresses what we want without ever compromising performance. That's the goal. That's the challenge of both the standards committee and also the community, because we don't want to close the door on all of our legacy, and we don't want to fracture the community into these new features are enjoyable by some people, but other people can't do them yet. So we're moving the entire community forward, and that's a challenge for the standards committee to make changes that continue to be backward compatible, that don't fracture the community.
Do young people find it sexy as a programming language? Do they actually want to learn it? Is this still a problem?
For an awful lot of them, the gateway is that they find out that games are written in C++, and that's the thing. It's like, the young kids play this game and they say, wow, what was this game written in? And it's like, well, it relies on a lot of performance, and we need to have a lot of tools and a lot of investment in producing these games, because the games have to be produced very quickly, and they have to be extremely efficient in using machine resources. So yeah, C++ is used in game development, and so that drives a lot of people into thinking, well, maybe I need to learn about C++.
One of the things I've always loved about my line of work is that programmers are so enthusiastic about their work, about programming in general, and most of them would probably, if they weren't paid to do, they'd do it anyway. And that's kind of how it works in college when you live on a student loan or some burger flipping job. But then exactly, and you make a name for yourself by working on open source projects. But then at some point you reach your mid-20s and find out that you still want to spend the better part of your waking time writing code, but that nasty things like bills and rent have cropped up, and all of a sudden, what makes a programming language sexy, among other things, is whether it gets you a job or not, and preferably a job in a sort of subset of the industry that you're interested in, whether that's games development or high performance financial computing or scientific computing or whatever it is. And there, of course, C++ becomes a very strong and very attractive proposition, just because there are so many C++ jobs to get around.
There is one question that I know the Qt enthusiasts among the C++ community would want to have answered. What the features might be in C++ 20, which are the most important, could you say, for C++ 20?
Oh, I have an opinion, at least. I'm sure Ivan can give the more competent technical answer on that one. But for a long time, concurrency has been something that was maybe taught theoretically in colleges, but that software developers have not had a lot of exposure to when actually writing their code, because the operating system took care of that. And that seems to change more and more. It becomes apparent that in order to get more performance improvements, programmers will actually need to design concurrency into software right from the start. So easy access to concurrency for software developers is probably the thing I would put to the top of my list of what is needed and where I would hope to see improvements.
I think one of the biggest challenges, following exactly on this, is to better exploit GPUs as opposed to just CPUs. And C++ is really good at exploiting CPU, but I think one of the things the standards committee is really trying to figure out is, how can we write code that looks and feels like C++, but will exploit GPUs, not just the GPUs that we have today, but the GPUs that we're going to have in 10 years. And that's a really challenging project. That's something that everybody's looking at. But there's other things that we have. One of the things that was, and I don't want to get too much in the weeds here, but there was this thing called SFNA, and it was something that was hard to explain to people, but it really gave you some interesting performance. And we don't need to know about that anymore, because with the latest release, we now can do concepts, which is basically a better way, more straightforward way, easier to explain way of doing what we used to do with SFNA. There's a lot of stuff in the area of reflection that, again, the committee is just beginning to unwrap how we're going to be able to do reflection so that it doesn't, because the easy way to do reflection takes a huge runtime hit, and that's just not acceptable for C++. So we got to figure out how can we do reflection so that the price you pay, you don't, as C++ would say, you don't pay the price if you don't use it. The solution to this is closer than the more general GPU solution, but the committee's working on both.
I think if I look at C++20, the big feature really is concepts, because as John mentioned, SFNA is basically made obsolete except for like a few obscure corner cases. So for Qt developers, Qt 6 makes C++17 the base standard, which also has some nice features taking away things which otherwise would have been solved by SFNA, like constant expression if. And there's C++17 has a lot of features, and for I think a lot of code bases it might be the standard rather than C++20 for the coming years, because I'm not sure like how modules, etc., will exactly be used. That's something the community right now figures out.
I agree with Jens. So even if we all adore C++20, C++17 is, let's say, the standard that the Qt people will mostly care about. For me, C++20 is mostly just a preview release for C++23, because there are so many nice things that are kind of not complete, but we're going to finish them in the next release. Concepts is probably the only feature that I consider properly complete. Coroutines, which would fix, let's say, all the problems for multi-threading and other stuff that Kalle mentioned. They're kind of in the language, but with no library support, so it's coming a little bit later. Range is incomplete, but you just get a taste of what's to come. So let's say C++17 is the release that Qt people should care about, and C++20 should be where C++ is going to be in the next, let's say, major release of Qt.
Okay. Well, thank you, gentlemen. This has been very illuminating. You've given us all a lot to think about. I think we better pull it to a halt there. And I'd just like to say, once again, thank you to Jens Weller, Ivan Čukic, I'm probably going to say your name wrong again,
He's used to it.
John Kalb, and Kalle Dahlheimer. Thank you very much.